go. There we go. Excellent. All right.
All right, Richard.
Thank you so much. Right. Well, good afternoon, everyone. Thank you for inviting me. And I really hope you'll enjoy this. We've got some 30 minutes together and a few more for your questions. And that's, of course, your chance to put me on the spot. Please ask the questions because these can, of course, be the most valuable part of the whole event. We specialize in high-performance engineering with the objective of world speed records. And that means we're after the greatest speed performance ever achieved. We quickly learned that if you just do the same as other record challengers, you're unlikely to get that record. So we have to innovate. We have to innovate in a big, big way. And innovation is absolutely everything. Innovation gives us the lead and the ability to produce something different and get a real new record about. And to innovate, of course, you have to have a real innovation culture in your organization. And we'll talk about that. This culture is very important because it enables you to innovate. And today, of course, as we all know, it's all about data. And like so many, I can't wait to see where this car industry is going to head off. You see, it's a real watershed time for an entire global industry. It's got to change. And I don't think we've seen anything quite like this since Henry Ford. Well, I wasn't around to see Henry Ford, but you know what I mean. We held a number of automotive records. Back in 1983, we took the world land speed record with my car Thrust 2, which took the record from the 1970s Blue Flame and reset it at 633 miles per hour with a peak speed of 650.88 miles an hour. That's Mach 0.84, or 84% of the speed of sound. The car actually got to within 7 miles an hour takeoff. So I guess we went as fast as we could while still remaining a car. Anyhow, we survived that one. It was a great car with a huge afterburning jet engine. And I could drive it to a lateral accuracy of 1.5 inches at 650 miles an hour. After that, we were involved in a huge three-way battle to achieve the first ever supersonic land speed record, where we were up against my good friend Craig Breedlove and the McLaren Formula One team. And there's a picture here on number 4 of the McLaren car. Have we got that? Yeah, there you are. We actually won this battle with our car called Thrust SSC, achieving the first ever supersonic world record at 763 miles an hour and on just 12% of the McLaren budget. Have we got a picture of that? Number 5. Coming up? There we are. This gives you an idea of what breaking the sound barrier on land's like. You can see the huge shockwave coming off the car. It created a monster supersonic bang, and that could be heard 40 miles away. And in the little village of Gerlach, and we're in Nevada there, basically it was shaking buildings. So this is proper motor racing, not this sort of round and round stuff, you know. So Thrust SSC was driven by Andy Green, and the world record still stands nearly 25 years later. So we're going to celebrate 25 years in October. We move on to number 6. In 2006, we worked with the JCB company to create the JCB Diesel Max, the world's fastest diesel car at 350 miles an hour, a record which still stands today. It's an extraordinary car. It's got 2 JCB 444 engines. They're not connected. They simply, one drives the front and the other drives the back, so they don't actually fight each other. And it's got the most extraordinary aerodynamics, which reduce the rolling resistance by an amazing percentage and made the whole thing possible. So the record still stands, and JCB are hoping to get back there again in due course, but somebody's got to break it first. Of course, we know today that just about everything's got to change. We've been through COVID, well, at least I hope we've been through COVID, and of course we've got global warming and decarbonization to add to the mix. We also need to take account of the auto industry's vast consumption of the world's minerals in order to produce short life products. We also live with extraordinary levels of global communication, which of course results in intense competition, much shorter product lives, and the need for ever greater innovation and response. And that means taking far higher levels of industrial risk, which many companies, of course, are often reluctant to do. But the name of the game now is that you have to take risk, otherwise you're going to get left behind. Going back to the land speed records for a moment, that's number 7. We achieved the Thrust 2 record, that's a 633 mile an hour record, with a very conventional car-like design. So in other words, it's a a 4-ton design with 4 wheels, one at each corner, and the very large Cold War afterburning turbojet engine. So number 8, to get to supersonic by comparison, that's number 8, yeah. The thrust SSC car weighed in at 10.5 tons and had 110,000 horsepower from 2 afterburning bypass engines. And to make the aerodynamics work, we actually had rear-wheel steer, a huge series of innovative design changes, which were achieved using CFD. And that's really interesting because that was CFD in 1992, apparently the first time ever used for a car, and supersonic rocket-powered modeling. We could have never have achieved it without the CFD and the rocket modeling. And the rocket modeling was quite something because the model cars would accelerate down the track there, 0 to 820 miles an hour in 0.8 of a second, so 40G acceleration. It's really exciting stuff. Now, I'd like to move on to number 9. And if you look at this graph, when we get to number 9, there we are, you can see the almost perfect correlation between the rocket data and that of the CFD. And so we were, of course, pioneering all this. We had no idea what the result was going to be. And when we saw this graph, we realized this is it. We got very similar results, both from the CFD and from the rocket testing. So the interesting thing was that to just increase the maximum speed by 113 miles an hour, we had to increase the power by a factor of 2.6 and come up with a safe supersonic aero design. And the car went supersonic officially 5 times, probably 6 times, and nothing like this has ever been done before. So as a team, we're very, very proud of what was achieved here. Thrust SSC was a huge and risky advance, which paid off big time, and this depended on the teamwork. You see, to achieve such huge advances, you need a very small team of very highly motivated engineers, a team where authority and responsibility are delegated to the team members, giving the team members the free opportunity to innovate, take risk, and find out what they could actually achieve and give them this opportunity. It's really very interesting because if we go to number 10, we can look at Abraham Maslow's hierarchy of needs, which he came up with in 1943. And here the highest level motivation comes in what he calls self-actualization, providing your people with the opportunity to find out just what they can achieve, and also to a certain extent find out who they really are. And if you provide that sort of resource for people, then of course you get these very, very high levels of motivation and extraordinary results. The difficulty is that within conventional hierarchical organizations, we find that they're just unable to innovate. So if you look at this slide from the American Management Association, can we have that number 11? Yep, there we go. You can see that what's actually happening here is your time is split between management and a function. And as you work your way up the organization, you're spending more and more time managing other people and spending less and less time actually doing anything. So I'm not quite sure where innovation fits in there. But innovation is a skill that takes many, many years to perfect. You see, what actually happens is you have to practice it continuously, and you have to learn what works and what doesn't work. It's a funny sort of human relations thing. And of course, you've got your backers, and you've got to take your backers along with you so that they will support you. Now, you can compare that with the traditional hierarchical company, and the traditional hierarchical company turns out to be really a money-making management fest. I mean, that's really what it is. And I love this slide from our friends in France. They've got a pretty jaded view of the hierarchy. So just let's have a look at that. Yeah, that's the birds in the organization. You can see the birds at the bottom are a lot whiter than the birds at the top. So there you go. So we don't really like hierarchical organization. We've been innovating now, as you heard, for some 40 years, setting those sponsorship opportunities. Quickly realized that the large clients' boards these people have never innovated in their lives, and they're never going to reveal a lack of experience to your team. So this makes the whole thing very difficult. Now we're on to slide number 13, and have a look at Thrust SSC. At the front, you can see the long needle nose, because on Thrust SSC, we had to install a Mach meter. This is the aerodynamic equivalent of a car's speedometer, but it measures this airspeed and relates that to the speed of sound, which, as you know, varies with temperature. The dashboard instrument has two pipes coming out of the back of it. One measures the air pressure on the pointed needle nose, which you can see there, and the other pipe goes to a point of steady aerodynamic reference, a reference point known as the static port. On an airplane, it's usually on the side up near the cockpit, but we didn't know where we were going to have to put it in a car. We didn't know how to find that, the position of the static port, and we were helped by a well-known American specialist company who decided very generously to give us a special deal. They would do it for us with 3 months of work and $165,000. Well, I can tell you, we didn't have $165,000. Even $1,000 was a stretch, and we certainly couldn't spare 3 months. We had a few talks on it, and I took it back to our design team who had new ideas. They solved it by lunchtime using a tap and a vacuum flask. It cost us just $50. So this is what innovation is really about. You're letting a team get on with it and come up with some really radical ideas, and you're supporting them. Today, of course, we're into a new world, which is likely to change almost everything. I must say, I find it incredibly exciting. For many decades, production car design was influenced by aviation. World War II aerodynamics created a series of beautiful aircraft designs, and this aero culture transferred to the outstanding cars of the 1960s. So if we look at slide 14, here's the Jaguar E-Type, the XKE, that beautiful car that Ferrari wished he'd actually made. So you imagine the commercial risk taken in producing a 150-mile-an-hour car like that in 1961. A beautiful job, but I'm not sure the aerodynamics helped the road performance much, because as you know, most cars operate in disturbed air from the vehicle in front. But hell, that car looks so good. So aero looks were the key selling point of that era. But now we passed on to something new. We passed on, led by BMW, the cars have got angular shaped lines, very uncertain aerodynamics. And now there's a growing interest in and influence in cosmetics and exaggerated features. If you have a look at some of the new BMW cars with a large, well, I don't know what you call it, a radiator at the front, it's starting to get very odd. And of course, we also have the electric and hydrogen revolutions upon us. And whilst the Far East are going hydrogen, Britain is heavily into electric here. But it is interesting, there's a lot to be said for hydrogen. We can see the huge sales of Teslas with their rather dated aero design. It's rather interesting that, isn't it? But the future for all this now lies with the oncoming or the incoming data battles. This is what's going to happen. Working from the streams of data, of course, as you all know, you can set up a program which will create a masterpiece with little reference to the initial design concept. And it can be something that performs far better than a human design. So this is where we've got to go. And we're into this now. We're into a new program, which it's just in its early stages, so I really can't discuss it yet. But what we're doing is designing a very high performance challenger with a design driven by the data. So function will, of course, win over form. It's a very high risk project, and we don't know the solution to this. It's like having a large equation, wondering, you know, how this is going to come out. It's a very high risk project with vast streams of data from CFD, of course, and from models. We're doing a lot of modeling now, which is very, very interesting. We're doing something that's never been done before. And we're introducing into this mix CFD modeling and data libraries on a considerable scale. And eventually, by the end of 2002, that's the end of this year, we shall have an absolute mountain of data to resolve. Much more data than, as you know, a human can actually cope with. And that's when we bring in the artificial intelligence to help us drill down to get to a final design, which we hope will meet most of the design requirements. So what we're doing here is creating a 100% function vehicle, and there's no styling and no cosmetics. This is going to be really different, and it's going to be really interesting to see what we end up with and whether it works as planned, because nobody's done anything quite like this before. But of course, all this may be flying in the face of the oncoming data wars for the automobile manufacturers. The cars are all getting very similar, as we see that. Speed, performance, and aerodynamics are taking a backseat now. Size is often ridiculous, and we're starting to see sort of bloated cosmetics. And this, of course, are all the symptoms, the time for a big change. Just as the same in the airliner world, where it's often very difficult to differentiate between a Boeing or an Airbus. They both look absolutely identical. This has happened, of course, because of lack of risk-taking and of wastage of resources in design and manufacture. So, in other words, nobody's been taking risk and pushing the technology forward. Here in the UK, having fought our way through 40 years of industrial complacency, I decided to write a book on our experiences to encourage the corporates to be a bit braver and undertake risk, because there are huge values and advantages to be got out of taking risk. If you look at number 15, that's our story. And there we are, yes. And it's called Take Risk, and Amazon seems to like it. So at least somebody likes it. So anyhow, I hope you enjoy it. But in the not too distant future, it's just not too difficult to imagine the manufacturers, the car users, the consumers and the people who are providing their loan cars and car rental and all that, and the media, each having their own massive and competing data operations, each with their own idea of the consumer's future needs. And where those three data streams come up with an identical or near similar design, there's going to be simply a massive industrial design demand with huge sales volumes. The cars, of course, of the future won't be aerodynamically beautiful any more than they may be, but they will be strange. But they will do the job for the consumer to a far higher standard than we've ever seen before. And we'll be very critical of the old bloated 2022 designs. And of course, the motoring industry journalists, they're going to have to change, because they're going to have to be data analysts to really understand the design reasoning and understanding of the design and to be able to write the reports. Our teams have all been about innovation, function over form. They may not be beautiful designs, but they've certainly achieved outstanding results. So data-driven innovation has to be the way ahead, and we have to encourage companies and executives to change now and take risk. I hope the book will help you to develop that killer instinct. So now for your questions, please. Have we got any questions?
Anyone who has
Right.
a question, please feel free to put in the questions or the chat, and panelists, please feel free to ask questions as well.
So Richard, doing something what no one ever done before. That would be a great question, but probably you won't answer that question, right?
Sebastian, I can't really go into details. We're at a very, very early stage. We don't know if we can do it, for God's sake, but we're having a go at this thing, and it's going to be very interesting to see how it comes out. So once we've got to a point of stability, we'll announce it. We'll make sure you guys know.
So what was your favorite part in all this construction? Was it the speed itself, breaking the record? Or was it years and years of technical preparation in all this process?
It's a bit of both, Sebastian. It's a bit of both. First of all, it's a huge battle to get something done like this. Like, for instance, Trust SSC, you're up against basically the British culture. Everybody says it can't be done. It's going to be dangerous. You're going to kill somebody, and they just don't believe it can be done. But you get going, and you find, with help of a few sponsors, you'll be able to get the thing together. And then there's a wonderful moment at the end, because when you're, for instance, I was standing at the midpoint of the course there in the Nevada desert, watching Andy come past in the Thrust SSC. It was an extraordinary experience, because imagine something the size of a locomotive coming past as fast as a fast airplane. In point of fact, it's faster than any airplane you've ever seen. It's an absolutely extraordinary situation, enormous supersonic bangs. And you wonder,
All right. I think we have a breakout here.
Sebastian, I can't see Richard.
Yes, I can see him, but I don't think he acts to be frozen. I think he is frozen.
Back again.
Richard, you're back. You were just frozen for a moment.
oh, I see. Sorry about that. Didn't realize that. No, I was just looking for more questions if we got them. Yeah.
Anyone also from the panelists, feel free to ask a question. I would ask a question again. Oh, so Mitch, yes.
Yeah, I have one. Richard, just a pleasure and honor to talk with you. I'm really curious, the level of innovation required to achieve the records that you've achieved. Can you inspire that as a leader? Is that more organic as an organization? We're talking about the future of automotive and tech, in our part of the industry.
Yeah.
And what can we learn from your experiences there?
Mitch, you're so right. It's about this, a lot of it is about the leadership and the corporate structure. If you've got a hierarchical structure, people are suppressed. They're told what to do, but they're very seldom given an opportunity to think for themselves. You've got to create an organization which is different, where people are allowed to be themselves and come up with their ideas, and you've got to back them and support them. That way you get the innovation. With what we do, Mitch, is extreme innovation, because basically what we're doing is using a lot of innovative concepts and ideas, and we're piling them one on top of another. So you're getting multiple levels of innovation. And of course, that's pushing up the risk really quite considerably. But we have to do that, otherwise we won't get a world record.
Fantastic. That goes against a lot of the structures in our organizations, which kind of explains sort of the Kelly skunk work approach, right? Like what you're talking about.
Oh, exactly. Exactly right. Yeah. And, one of the big difficulties is actually selling the sponsorships for a thing like this, because you're dealing with boards of hierarchical organizations, and they just don't believe it can be done. And often what happens is, and this is a really interesting one, if you're dealing with a very, very large organization and you're presenting in front of the board, after you've gone, they invariably ask each other, could our organization do this? And they come to the conclusion they couldn't, so they won't back you then.
Very good. Thank you.
There's a lot of sort of suppressed arrogance in all this.
I'm curious, was there sort of a tipping point or turning point when you felt like you've built the right team, the right combination of suppliers, or is it just an evolutionary, it kept progressing as it needed to go?
It's evolutionary. So what happens is you start off with a collection of people who have obviously the right experience to do a thing like this, and the personal motivation and willpower to actually do it. And the project advances. And as it advances, of course, the pressures get greater and greater on the team. And from time to time, people drop out because they simply say, look, this is just getting too difficult for me. I feel out of my depth. I don't think I can really contribute. And the extraordinary thing is that because it's a dynamic team, the rest of the team realize that that particular person may be about to leave, and they have somebody else in line straight away. It's an extraordinary process. So the organization renews itself all the time and keeps on developing very, very fast.
Thank you so much.
Thank you.
So Richard, I'm also just thought about a question where you were talking about this, as we also have a very international audience here. I know you have big teams and also multicultural teams. How does your team consist of from a multicultural perspective? Because I know you're working in the US, you're working in the UK, and other parts of the world. How does your team consist and comes together here?
Sebastian, it's a very small team. There's an awful lot of communications, because of course we have wonderful communications today, and there are experts dotted all over the world. Who we can, with a bit of luck, we can get to communicate with. But we live in a world of extreme communication. So one of the projects that we did after the Thrusters at Sea was the Bloodhound Project, the first 1,000-mile-an-hour car. Unfortunately, this project got wrecked by the UK government. The government gave us an offer to support it financially, which is terrific. And also at the same time, we'd signed a major contract with our friends in China, the Chinese team. And we were well on our way. We were looking very good. But then the British government decided they weren't going to pay. And our Chinese friends said, well, we're not going to handle this by ourselves and be the only ones. And so they stopped. And we lost the whole project. which is a great shame. But that project was used to stimulate education, and we became the largest STEM program in Britain. We were doing 127,000 kids a year engaging with them, and it was having a huge effect. And it was also being followed all over the world in 200 countries. So there's terrific sort of educational power behind a program like this, providing, of course, you're innovating and providing you're making all the data available to everybody.
Okay, that sounds great. So do we have any more questions, or should we wrap up with Richard? And we can start with the next presentation.
Can I ask one more question, Sebastian?
Yeah,
we
sure.
could go 3
We got
hours.
plenty time.
But
Good.
I'm really curious, with the advancements in technology and the time period that you've done all of this, Richard, I would imagine there were periods where you're kind of starved for data.
Yes, you've gone. Sorry, I've lost you.
Oh, okay. Can you hear us now, Richard?
I can hear you now. Can you repeat?
Okay.
Thanks.
Yes. During this period of time, you've made all these incredible innovations. Imagine there were periods where you felt like you wish you had telemetry data about certain information, and as technology advanced, you were able to start to add that gathering kind of data. Today, we feel like we have telemetry on everything, and it's easy to add it. Has that changed how you approach solving this speed problem, or how's that influenced how you approach this?
Well, of course, it becomes fascinating because during the early days, when we didn't have great volumes of data like that, you were dependent on the designers, basically taking a bit of a risk, really, one way or another. And then, of course, when you get the data, and you get huge quantities of data, that actually slows the whole process up, because you may get some data which simply doesn't match up, and you're just wondering what on earth's going on there. So it's just a new chapter, really.
Very nice. Thank you.
Thank you.
Okay. Thank you, Richard, for joining our little session, and you're welcome to stay and learn a little bit more about what's actually eating the world at the moment, the software. Yeah?
Right, Sebastian, that's going to be most valuable. Thank you so much.
Yeah, thank you. And that brings us to the next point of the agenda. So my two colleagues, Alex, he's also located in Germany, in Europe, same as Richard in Europe, and here in the Frankfurt region, and also Scott from the East Coast, both solution engineers at Couchbase. And we chose the very inspiring title from fool-driven to data-driven, as Couchbase is a data management NoSQL software. But I just leave it up to Alex and Scott. The stage is yours.
Yes, thank you very much, Sebastian. So let me quickly start sharing my screen here for the presentation. Hope everyone can see that. And after having heard now from Richard about all these land speed records, which was really impressing, let's get a little bit into the discussion about new trends and future technologies in the automotive industry, which is only at first sight only a technological discussion, but we will see that here in a minute. But collecting of data is not new to the industry. If you think about a car today, which has about 100 or more sensors to log the technical state of what's been happening and so on, or think about a Formula One racing car that has about 200 of these kind of sensors collecting around 450 gigabyte of data during a single Grand Prix race. And if you take that amount of data and think about a fleet of delivery trucks or the total number of cars of a single brand sold in one country, and get an impression about the amount of data that cars collect today. And this data needs to be transferred and stored mile by mile, day by day, year by year. And yeah, I think that shows why data platforms play a central role in the automotive industry today, but as well in the future. Now, that's not only sensor data we look at. If you look at the current trends and future technologies and ongoing developments, that these are more and more about personalized services. So if you think about sharing versus owning concepts, if you think about mobility as a service, if you think about a digital customer that uses a car today, and these personalized services, just think about your own Apple ID or Google account that you use with your smartphone. You will have the same for your car, your Mercedes ID, your Ford ID, your Tesla user profile, that allows you, that the car identifies you as an individual, and also the mobility service you are using will be able to identify you as a user and deliver a personalized service to your needs, right? And this is maybe, if you take at that picture here, we see that the customer's role and the industry's business model are undergoing a subsequent change, and a customer is becoming more and more, let's say, kind of a consumer of services in the future, than rather being a car owner like it was or is still today, or maybe a mix of both as well. Yeah. So for instance, why should you pay for a heated seat in summer or when the winter next year will be not very cold? Yeah. In the future, we'll only pay on demand for extras. How about that? Yeah. BMW, for instance, has announced a subscription model for smartphone-based virtual key, remote start, and heated seats. And Porsche already offers today range optimization and lane keeping assist for a monthly charge. And that's at least for some of their electrified models. So you see that there is a change here in all these levels. On all these levels, the customer role changes, the customer retention changes a little bit. So a service is faster canceled than a car that is owned. And you see that the business model is also slightly changing from being just a manufacturer to become a more on-demand type of service provider, yeah? As well as the service model, the payment model will change from buying to a more subscription type of model. Yes, but now from an IT perspective, what does that mean? Well, this can be made very simple. These are all consumer-centric use cases that will typically be delivered by a mobile app or a car embedded application. Yeah, and if you look at the use cases, these are typically consumer-centric type, like identity and access management, session store, or a user profile storing, but also, of course, IoT data management, so handling of sensor data and so on. And all these use cases that are use cases that NoSQL is typically designed for, to give you the highest level of flexibility and agility for developing. But yeah, use cases alone do not make a great customer experience. What you also need is a data platform that delivers and serves these use cases with a performance at scale. I mean, it's an easy job for any database to be fast for 10 or 100 customers. But when you go up to 10,000, 100,000, or even millions of customers, and that's what Couchbase is designed for, that's where we come and play, we deliver the fastest database at scale. And that's why our customers choose us and rely their business critical use cases on Couchbase. And I have chosen just some small examples, and Scott will come up with some more in the part when it comes to mobile use cases. I think it's important to understand that customer experience for these consumer centric type of use cases is a key factor. You want to deliver high availability, so this has to be available 24/7 hours, 7 days a week, every day of the year. And you will also need to be able to adapt to changes on demands of the customers. And you see that customers that have chosen Couchbase, especially for these consumer type of use cases, that are handling this with a very small team of operations, and that they deliver a superior customer experience at affordable cost, because that's the next important success factor. You keep an eye on the costs as well. And if you think about the challenges you have, you want to modernize application or create new ones. You want to keep your infrastructure flexible and up to date without a cost explosion, and keep your organization and the operation of this infrastructure as efficient as possible. Then you will find that Couchbase will deliver here a database platform that helps to achieve these type of goals, or to deliver these kind, or support these kind of key factors. Now, just to make an example, what I'm thinking when talking about a data platform, and this is just an example of a manufacturing process. So from the manufacturing of whatever, you typically, if you look today into these type of processes, you will find that each and every type of the process here will have its own point, its own data to be collected, which will then be transformed and extracted and loaded up into some analytics database at each step of the process. And you will have, let's say, sort of a siloed look at the data in a lot of cases. But what would be the solution? It would be a consolidated data platform instead of what I would call a Frankenstack monster, because think about that, there is not only a database that you will have to deliver, there are also services to be orchestrated around a database that make up a data platform. Think about a full text search that you will need for analytics. Think about things like analytics themselves. Think about mobile use cases you want to achieve there. So it's a huge platform that you will have to orchestrate there, and that's where Couchbase also can help to build a single comprehensive data platform for these kind of use cases, but also other type of use cases as well. This will help you to develop faster, to be able to deploy your applications and the databases everywhere you need to, be it in the cloud, be it on premises, be it on any device, including mobile. And that's the most important thing, deliver performance at scale. Yeah. So just to make that a little bit understandable, Couchbase delivers there more as just a database. It's a real data platform that delivers query services, mobile analytics, full text search, indexing, and so on. So everything that you need to handle the data of any application and use case that you might think of, and that with a really high level of performance. So let's just take a small look here at the manufacturing and logistics architecture. So how does this data platform fit into an enterprise solution infrastructure? That's important if you're thinking about today's corporate solutions. So no matter if you use this from a cloud, from an own data center, so there are different approaches here. Then you see here that a Couchbase as a process platform can be used, as well as for these consumer-centric use cases we talked before. And you see that here, these independently multi-dimensional scalable services that make up the heart of Couchbase. And that's important that they are multi-dimensional scalable. So you can scale each of these services individually, but keeping that as a complete platform on a single cluster, not having to orchestrate different type of products. It's all in one platform at that point here. And that will be then as well added here by a web tire that can hold also a sync gateway, how we call it, that communicates with user applications, and especially this is an approach for mobile user applications, which we will talk in a minute about. These type of user applications will collect data, consumer data, sensor data, and will first of all store it locally. So we have here for this type of mobile applications sort of a offline first approach. That's important because there are two lies about connectivity, mobile connectivity. First lie is you will always have connection. And the second lie is you will always have enough bandwidth. We all know when going mobile, that is not always the truth. Yeah, and looking at this a little bit closer, and I think that would be the point where I would like to hand over to Scott. I think, Scott, you wanted to go and lead us here through the typical mobile type of use cases. Maybe you can take over at that point. Just say next when I should flip over to the next slide.
Okay, or I can just switch it to mine real quick.
Oh yeah, we can do so. So I just stop here then. Okay. Yeah, that makes it easier.
All right, you should have the same slide that you just had up.
Yeah, cool.
All right, well, great. So where can we look at, when we think about bringing more technology and more integration into a connected car type of experience, or mobility as a service experience, or just making use of all that telemetry data that sensors attached to engines and in-car electronics and climate control and everything else are there. How much are we really using that data? Are we just using it to blink a warning light on the dashboard when the engine temperature is too high? Or can we use that for more? Can we use that to let somebody know that it's probably time to bring the car in for service, or to recommend new enhancements, or even deliver new enhancements to the car directly, as is starting to happen today. But where can we look for inspiration for where this is going to go? And I'm going to say, look bigger. Look at airlines. Look at other large transportation industries. They've been mobility as a service from the very beginning in the commercial aviation, shipping, cruise lines, trains, you name it. Those are huge capital investments that don't make sense for the average person to own individually. And that, I think some of the trends we're going to see in those industries are going to continue to make their way down into the automotive one. So for example, Carnival Cruise Lines makes enormous use of Couchbase and our mobile capabilities because these cruise ships are incredibly connected. Everybody has a necklace or a bracelet on the cruise that connects to their account and lets them pay for stuff, get directions. It tracks everything, makes suggestions, gives everything they need, and provides a much more connected experience. And Couchbase is what enables them to do that. one of the challenges that these cruise ships face is they have an onboard data center, but connectivity to the internet at large is, while possible to do via satellite, very expensive and kind of slow. So when they are not at port, they have a real reason to have a really robust offline capability. So that's one of the things that Couchbase has brought to the table for them. Same sort of example at United Airlines, right? They've got, you can see how many different use cases they use Couchbase for. If you fly on United, you're interacting with Couchbase at some point along the way, whether it's pricing of your ticket or the drink you just ordered with the crew. When they pull up, when they have the little handheld device that looks just like a cell phone, they are using a Couchbase mobile integrated database to deliver that. It doesn't matter if they have connectivity or not, it'll resync later on. So that's a great example for a couple of things that the larger travel industry can tell us. And United Airlines has a big backend that has all kinds of stuff. It's got a key Hadoop data warehouse, key value stores, more traditional relational databases. And they have a Couchbase cluster and sync gateway. So this stuff is all connected. The Couchbase database pulls in data from other things through the sync gateway. It syncs with those mobile Android and Apple devices that are on the plane. Another use case there is all of the emergency procedures stuff is on a tablet now. It's not a binder anymore. And all of that stuff is on Couchbase Lite on a tablet. And then their web apps also can directly interact with that Couchbase cluster. So all of it ties together and is seamlessly available. Another industry we can look at is more of the heavy equipment. General Electric makes all kinds of stuff, but all of that, all of those big devices, whether they're jet engines or power generation equipment, have again a huge amount of telemetry data, and the GE Predicts IoT platform provides a way for them to integrate that, to ingest that data, integrate with other systems, and make sure that they get an ongoing flow of data without disrupting the user's experience, and get that information to their field workers, no matter where those field workers are. If they're at a hydroelectric plant out in the middle of nowhere, it's something that they may not have. There may be no 4G, 5G connection out there. They may not be able to get onto public, to a guest Wi-Fi network to connect back to the office. And here's another example of a reference architecture, where we've got the Couchbase server. That sync gateway is really the key. That's what makes it all work. That handles all of the communication between the light database, the embedded database on the device, and the Couchbase server, the enterprise class NoSQL database that lives on premises, in the cloud, at the edge, wherever it needs to live. The sync gateway it manages all of the synchronization as connection is regained. So just to keep on time here, I'm going to go real quick. What are the takeaways from this? First and foremost, the solution absolutely, no question, must work in a disconnected state. People expect that now. People expect, if your car cell phone integration quit working when you lost cell phone signal and your navigation cut out, you wouldn't be happy about it. The scalability and flexibility to meet future requirements are also not an option. Those have to be built in. And this is a huge business opportunity. Look at the success Tesla has had marketing new enhancements to existing owners, whether that's performance enhancements or improvements to the autopilot system. Those are ways for the auto industry to continue to both bring value to their customers and generate revenue from their customers. They don't have to wait till they need to buy a new car. And that will also help make, hopefully cars last longer in service and consume less resources. And then, that strong edge computing platform will also enable some of those mobility as a service applications like we're seeing with Uber and Lyft. And that's what Couchbase is bringing to the table for this discussion. If we've got some questions, happy to, Alex and I are happy to take them, or we can visit those again in the panel as well.
Yeah, I think everyone will see you back in the panel. So I would say maybe let's move on to the next presentation, if that is fine with everyone.
Sounds good.
So Nishai, he's our Red Hat speaker. His main topic will be all around open source, of course, also about OpenShift, and also highly specialized on automotive. Nishai, are you ready?
Yeah, Sebastian, sure. I'm just trying to turn on my video. Maybe you should give me access for that.
Where are you located, Nishai?
Yeah, I'm based in Munich.
Good. That sounds very automotive as well.
Perfect. I'm just trying to start my video. Sebastian, maybe. Okay.
Yeah.
Now I got the thing. So maybe
yes, I can see you.
To see my screen now.
Yeah.
So let me share my screen first.
Yeah. I can see your screen. And also the Red Hat Automotive Overview. All right.
Perfect.
Looking forward. Thank you, Nishai.
Thanks a lot. Thanks for inviting me for this forum. Good morning, good afternoon. I know this is a very global webinar with participation from all over the place. So now I would just give a quick introduction of myself. I am myself Nishal. I'm responsible for automotive ecosystem development at Red Hat. Currently, I'm based in Munich, and automotive is a special focus area for Red Hat. I will just walk you through what's our offering in this space, what exactly are the new things that we are bringing in, how does it align with the topic of today. A quick overview for those who are not aware of Red Hat, a bit of statistics. When was it found? Currently, we are about 19,000 employees, $4 billion revenue. I think the statistics apart, the number apart, what the most important message from this slide is, we are an open source company. I mean, whatever product that we do, whatever is the philosophy of the product is grounded in open source principles. I think that's a key takeaway from this slide. I mean, we are the only first company with $4 billion revenues, all based on open source. We will talk a little bit more on open source. I think there's a panel discussion, what exactly and how does that relate to some of the topics that we have been discussing. So when I tell about open source has been the source of revolution for all the industries, be it airline, telcos, healthcare, banks. 100% of that which we are running is currently based on Red Hat technologies, and we are extending the same to automotive. Automotive traditionally has been very proprietary driven, has been very orthodox, but we do see now the floodgates have been opened, and we have seeing the same kind of revolution that we have been talking earlier. I think there was a mention of Tesla, there was a mention of various other companies. I think this is exactly where the industry is headed. So stepping back a little bit, we've been talking about all the disruptive companies, Tesla, Uber, AWS, and all these companies, but Red Hat was founded in '93, even way before all these companies existed, and we have laid the foundation of open source, which was a trigger for the revolution, be it Android, be it open banking, be it all the technologies that we have been discussing. Open source has been laid the foundation for these kind of a disruption. I wouldn't like to go deep into this topic. We'll probably touch upon that in the panel discussion. What I would like to touch upon is the open source has been the foundation, the infrastructure that would provide you to build and integrate your higher application layers. So some of the use cases I would say is it avoids vendor lock-in, it provides more independence, you're less dependent on having proprietary technologies. And what exactly is Red Hat really providing in this opens is we provide you the enterprise grade support for these products that are built on open source. And that's the enterprise model upon which we have the revenue model, what we saw as 4 billion. And the flexibility, scalability, and all the kind of innovation that is needed to build the future of all the kind of disruption and innovation, open source provides the foundation for that. So coming back a little bit on the topic today, I mean, typically Red Hat has been focusing a lot on the data center side of things, whatever we speak, be it the cloud technologies, the containers, all of that have been centered a little bit more on the data center. So as we talk today about vehicles and IoT and all these kind of things, it's moving more and more as what we call as edge computing. So whatever technology, whatever products we had, we are developing a new portfolio. We are moving more and more towards the right to really address the computing of edge computing technology. So traditionally we do see, I will share more in the upcoming slides, what are the kind of new products and what are the kind of new technologies that we will be probably bringing into the automotive, which when we talk about automotive or IoT or remote device is moving more and more towards the right as more or less how we position that as a device edge. So summarizing the previous slide, what I was mentioning was our current product portfolio is more on the right side. We address the enterprise edge, the operator edge, the provider edge, but moving forward, we are making it more vertical focused, more industry specific. We are getting more into industrial or manufacturing, automotive, and more, and we anyway have a great market presence in telco. But when we talk about telco and the 5G revolution that is driving connectivity with various edge devices, I think that is what we call as the Red Hat edge, and that is where we will see lot more new portfolio coming into this space. So coming very specific to automotive, we all have heard CASE, ACES are the main trigger points for all the digital transformation, connected, autonomous, shared, electrified. We as Red Hat would also extend more that into the enterprise IT and the industrial internet and the manufacturing space, because for us, automotive spans not only the vehicle, it goes end to end from inside the vehicle to the back end, to the manufacturing, to the factory floor. And also once the car is on the road, how do you tap into the data? So this is exactly what we are mentioning when we talk about the whole life cycle of the automotive as a vehicle. It's just not the car. We engage with the ecosystem right from the R&D phase, where where we have new ideas with the customers. How do we develop that? What are the kind of new ideas which we can develop to really make it as an offering? Then we have the sales and marketing. This is more to the how do we have the sales and the portals, the dealer networks that really helps in selling the vehicles to the market, that is offer to order. Then we have production logistics. This is purely related to the factory floor, the manufacturing, the industrial edge. And after sales and service is something once the vehicle is on the road, this is where the big action is currently happening. You have petabytes of data. How do you tap the data? How do you build the intelligence of the data and have this after sales and service kind of a model? And all of this are based on our philosophy of open source, the hybrid cloud, and the enterprise products that we have been discussing. This is some standardization and open source initiatives that we are part of in the industry. As we said, open source and is all about ecosystems. It's being part of the ecosystem, working with the ecosystem to develop the product, and we do support a lot of industry initiatives in all this area. We can talk about ELIZA. This is embedded Linux in safety applications. This is a new initiative. We are supporting the mobility initiatives. We are supporting future mobility in the UKI region. Then when it comes to production logistic, we are part of Eclipse, open manufacturing platform, and also a lot of new initiatives in Fireware and Gaiax, all those things. So just to state some of the public use cases, which is already on our websites, we are in the public forum. So all that I am showing up here are something which is already in the public space, starting from ZF, where the autonomous driving platform is based on our technologies. I will touch upon a couple of these examples in the later slides, what were the autonomous driving for BMW, virtual testing for Volkswagen. I will give a little bit more information in the subsequent slides. So yes, now getting a little bit more onto the vehicle. When we look at vehicle, we can really compartmentalize into two areas. One, which is vehicle onboard, that goes inside the vehicle, and vehicle offboard, that is typically where the back end of the vehicle is. Irrespective of onboard or offboard, our portfolio based on Linux, containers, middleware technologies forms the base and forms the foundation. We will be using the same technologies that can scale all the way from vehicle inside the vehicle onboard to the back to the offboard. So elaborating this picture a little bit more, when we talk about vehicle onboard, the new investment and the new products that we are getting is the in-vehicle operating systems. This will be completely an industry first kind of initiative where open source based, safety certified, ASIL B grade kind of operating system. This as of now we have Linux in the cars, that's not a new thing, but the way it has built based on open source model, and it will be something revolutionary for the industry, and that is exactly currently what we are building. And when we extend the same principles onto the back end, we are already being used by many of the car makers, as I showed on the vehicle offboard and the cloud space. What is interesting that is really new to the vehicles, we have been referring to Tesla a lot in the earlier things, is how do we connect the vehicle to the cloud? How do we enable the data can be seamlessly transferred from vehicle onboard to the offboard? You will have various kind of connectivity pieces, be it 5G, be it the connectivity forums, and they are very specific to automotive. Quite a lot of standards that are very if we talk about WP29 UN regulations that is kicking in another 2 years. So all these kind of a connected vehicle network edge is what we are really focused with some of the ecosystem players to develop that. So if we extend the same philosophy to the factory and the manufacturing space, we have a mirror image, I would say, because we are using the same what do we call infrastructure components and the base technologies to develop the support the manufacturing use cases as well. For example, when we look at the process, production process, shop floor, plant level operations, all these kind of use cases can all be built on the same technologies of Linux containers. So that's what we were mentioning, be it the vehicle, be it the manufacturing, we will be using the same open source technologies, the same what do we call hybrid cloud technologies, Linux containers, but we will be bringing more certifications and industry specific what do we call technologies that are needed for based on the use cases. So when I was referring to connecting the vehicle to the cloud, we are working, as we said, with the ecosystem. This is an ecosystem play. We believe it is not, we have to collaborate with multiple partners, and there are specific partners with specific strengths. So we are working with certain alliances, for example, with the eSync Alliance, to see how we can bring in standardization to some of the back-end OTA infrastructure that can be run on, for example, OpenShift. So we have certain approaches and certain white paper, which is in the public domain. And this is more or less like a reference to say, why reinvent the wheel when you can almost standardize most of the infrastructure components so components that can be the plumbing for developing the connected vehicle. So we have the link, we can share you can have a deeper look into what exactly we are building in the OTA space. Similarly, when we look at the automakers, the tier ones, so this is the eSync consortium, which is actually trying to bring in the industry partners. So this is an effort from our side to explore how such a solutions can be run on Red Hat technologies. Extending the same to the manufacturing space, we do see this can be more or less like a IoT 4.0 kind of a use cases, where we have various kind of remote devices which is connected by probably the 5G connectivity, and how as a backend can all run on the common OpenShift and the hybrid cloud technologies. So we are working with some of these demos, some of the use cases that can support both the vehicle and the manufacturing kind of a use cases. So I was referring earlier some of the public use cases. One of the case that I would like to highlight is the BMW use case. This is again on our websites. This is all over on the social media like YouTube, where you can see this in more detail. This was also winner of the 2020 Innovation Awards. So if you really look at autonomous driving, also the topic of the day today being the data management, it's once the car is on the road, the real use case is how do we manage the terabytes of data that is really provided by each car. I mean, if you really look at the cars that are running the BMW on the roads in the Unterschleißheim, some of the test cars that are providing almost 50-70 terabytes per day per car, and the whole cycle, the learning, simulation, into what do we say, how do we validate the data, how do we build the intelligence of the data. We provide the infrastructure that can really be used to build that kind of a framework. And this is again the solution that is provided by one of our tier one supplier, DXC Technologies. You have a white paper of a solution, how this is developed, all based on Red Hat technologies of OpenShift, Linux, the storage devices, and the Ansible automation. So you have the complete end-to-end data ingestion lifecycle model that is actually used, and you can have the more details of this solution description on the websites. And another interesting use case, I mean, this is what I was telling, the newer cars is no more, what do we call, a metal bender kind of a thing. When we look at the modern cars with so many kind of interfaces, ECUs, and connectivity things. It's a very tough value proposition of how do we test this whole car before the car is released onto the market. So we were working with Volkswagen to provide that kind of a vehicle testing infrastructure. If you really know a typical car, it consists of electronic control units, almost hundreds of them. How do we really simulate all these ECUs and in a virtual manner in a cloud way? So even before you have the hardware, you can actually simulate that and run them on a simulated platform. This project is called Connected Mixed Reality. You have a lot of information which is actually present by Volkswagen themselves and also jointly with them. This was also nominated for this year's Innovation Award, and it's been a great collaboration with Volkswagen to build a first of its kind platform for their entire, what do we say, as you know, CARIAD, which is now Volkswagen software organization that caters to the complete as a group IT. So the overall concept is how we can have a scalable testing infrastructure, and it can simulate all the test cases that are evolving. For example, you need a kind of a cloud infrastructure which can simulate, if we know millions of use cases, that can provide scalability, so that you should be able to spin up all these containers in the cloud depending on the use cases, and also have a way to clean up and actually simulate the next test environments. So this is a kind of a project which we are doing with Volkswagen and their ecosystem partners and all their suppliers to provide this kind of a modeling and also a cloud infrastructure to develop this virtual test environments. Just looking at the time, I probably have to cut short some of the details. As I said, all this information is available on the website, and would love to provide more information if you need specifics about this. So I'm looking, I think I've already overshot by 2 minutes. Any specific questions, would love to take it.
Yeah, I think, thank you very much, Nisha. That was really interesting. I think any question, please post them in the chat, and we will follow up on them later. So we can use this time to start with our panel, because I think there's much content and a great moderator with Mitch. So Mitch, you already were in conversation with Richard, and now, yeah, I'm giving it's all yours now, and you will handle and moderate the panel. So please.
Thank you very much, Sebastian. Let's have our panelists go ahead and turn on your cameras. We'll all get on, and thank you, Nichelle, and everyone for the previous conversations, presentations. I think that sets us our dialogue very much. We've got a really great panel here. Again, my name is Mitch Ashley. I'm CTO with Techstrong and also principal of our analyst firm, Techstrong Research. And pleasure to kind of moderate, host this conversation. I want each of our panelists to just take maybe 2-3 sentences, tell a little bit about yourself. We don't have too much time to give a full bio or anything, but I want to, so everyone has a context for where you're coming from as part of our conversation. So Andreas, would you start first?
Yes, thank you, Mitch, gladly. So my name is Andreas Darmawan. I'm the VP of Business Operation at CloudBees. And I've been on the DevOps journey since 2011. When I joined Electric Cloud. And then about 3 years ago, Electric Cloud was acquired by CloudBees. Throughout that, I've been in these 11 years, I've been developing pipelines, DevOps, DevSecOps pipelines for various industry, including OEMs in automotive. So today I'm happy to share my take, whatever wisdom that I have obtained for 11 years implementing DevOps and DevSecOps pipelines.
Thank you. And thanks to CloudBees for sponsoring. Thanks for being here, Andreas. Jeffrey, would you like to go next with Red Hat?
Certainly. My name is Jeff. I go by Jeffro, and I'm a community architect within Red Hat. So that means that I kind of help to guide our relationship with external communities, particularly open source communities. And I work directly with Nishal. Very glad to be working on automotive. It's a long-standing interest of mine.
Oh, wonderful. Thanks, Jeffro. Alexander, we heard from you in your presentation. By the way, great presentation. Thank you very much. Do you want to say a little bit more about, in case anybody joined late, didn't get to hear that, who you are?
Yes, sure. I'm Alexander Schlüter, working as a solutions engineer at Couchbase. So let's say being the technical good conscience of our sales colleagues and marketing teams. I have a focus, let's say, a little bit on customer engagement as well, on user experience. That's why I focused on that one as well in the presentation, so that we see that data is not only IoT, but also the consumer himself.
Fantastic. And last but certainly not least, Scott, also from Couchbase. You're on mute, I think, Scott.
I am. I'm Scott Fallon. I have the same role as Alex does, just on the east coast of the U.S. and instead of in Germany. My background, but I'm less than a year at Couchbase now, coming up close to a year now. My background actually is in the performance and monitoring space for relational databases, Microsoft SQL Server in particular. I spent quite a bit of time at SentryOne, helping people you continue to keep those legacy database systems working well enough. But there were so many things that I spent loads and loads of time on trying to continue to find a bigger hammer to put the square peg into a round hole. Where a lot of those cases, if they had just migrated that application over to Couchbase, it would have been much more scalable and flexible, and they probably wouldn't have had some of those challenges. So it's fun to be here, and I'm enjoying working with our customers and helping to, as Alex said, be the technical side of the sales and marketing side.
Fantastic. And you, like all of our panelists, have some great, fantastic experiences to share. So appreciate it. And of course, thanks to Couchbase and to Red Hat and also to AWS. Unfortunately, Oscar Medina, who is on our panel, couldn't stay for the panel. So we'll have you here in spirit, Oscar. So thanks to Techstrong also for sponsoring. So let's jump in. We have a great content leading up to this. A lot of it talking everything from manufacturing side to the user experience to how we consume, from subscriber to owner of vehicles, things like that. I think it'd be great to have each of us say what we think some of the most impactful changes in the digital experience that's happening to our industry. Maybe Andreas, if you would start us out.
Yeah, thank you, Mitch. Yeah, we heard from the previous presenter about the fact that selling a car is no longer about selling a car, right? There are services that subscription services that are about to be sold even more. And we talk about the fact that the user experience is also changing, right? OTA is actually now expected, right? So the automotive OEM is actually going through revolution because of two strong forces, right? A revolution that is happening on the EV side, right, for clean energy. But also what's interesting is pandemic, it actually changed the way we work. So given these two forces, right, revolution on EV and the way car is being seen as a transportation, but not only just as a transportation, but also a place where we consume our services, this actually create two interesting changes, right? OEM will need more skills because they are skills that we never thought that it's needed in OEM automotive, building a car. Now it's needed, right? For even financial services now becoming a supplier to the automotive industry. And then we need more powerful hardware. We need more mechatronics. We need more software layer that is embedded in all of many different components in the car. Okay, so there is that forces, and then pandemic also forces all supply chain in the OEM industry to work remotely, right? Now, with all of these forces, right, what are the requirements, key requirements that are changing? Right now, we want to figure out, given the complexity of the supply chains, and we have experienced the supply chains debacle, right? How can we actually build high quality integrated hardware and software securely, right? Not only high quality, but also how do we build it securely, right? How to handle the issue of man in the middle, right? Attack, for example, or hacking. And then when we see the explosion of hardware and software combo, one of the biggest thing that is getting harder to do is actually bill of materials. See, the concept of bill of materials is already very common in PLM, right? For hardware. For hardware, PLM solution already mastered that. But now in software bill of material, that is still wild, wild west. Especially, how do you actually have a pipeline for hardware development and a pipeline for a software development, and they're all working at different speed? What are the interaction points between those two pipelines? So there is a development speed different, and also, but they do depend on each other. And the component that makes up a motherboard versus the component that makes up the software library that support that motherboard, they are separate, but they do need to be tracked together. So a combined bill of materials for hardware and software, it's a new requirement, right? And so given that, what are the solutions? To me, there is no silver bullet to this solution. There is no one box solution that can solve all of this because of the diverse need of skills and team and geolocation. So to me, when I think about my experience helping OEMs, what I find is we have to embrace diversity because there is no single one box solution. So we have to embrace diversity. And this is a journey. It's not like, oh, let's just buy a solution from that vendor and then flip the switch and then everything is good. No way. It's very hard to align everyone, right?
Yeah, I think that plays really well, Andreas, into what we heard from Michelle with Red Hat talking about this diverse ecosystem, really, right?
Yes.
You think about it as supply chains and workflows, but it's really a complete ecosystem. Jeffro, I'm interested in your perspective coming at it from platforms and open source, but also, of course, Red Hat's working with many partners, including folks here. What are the things that really have kind of fundamentally changed or are changing about how we have to rethink of how we create software and design automotive, not just systems, but services that go with them, customer experiences?
I think that hits on the crux of the issue, at least from our perspective. And I would reflect also back on what Andreas just said about not being a single solution and embracing diversity. Really, the as Nishal also said, the primary method that Red Hat uses to approach these problems is through open source and through community-driven development. And so, I would love to, wax poetic as some of the others have done on the user experience from the point of view of the driver, but really where we're coming up with our points of innovation are really within the developer network, developing software and in working directly with hardware manufacturers to develop new and innovative hardware specifically for the vehicle. And it really is a fascinating thing to watch. There's an old saying in open source that you can either, if you want to go fast, you go alone, but if you actually want to go far, you need to go with others. And this actually goes back to what Richard was saying about the hierarchical organizations being an impediment to innovation. I'm looking over at my notes here. Open source by nature is non-hierarchical. It is egalitarian, and everybody works together on the same problem. And one of the ways that we do that is through foundations and open source projects that have rules. rules for engagement is one way to look at it, but we like to look at it as rules for collaboration. I mean, my head is kind of spinning with all of the different ideas that people have been talking about. There's been a lot of talk about data-driven innovation and about the evolution into services. And all of these things are software-driven from our perspective. And so there's a great deal of opportunity here for, one of the things I noticed, and it's kind of I feel like it's kind of an elephant in the room, there aren't any automotive manufacturers on this panel. We are all the builders of this innovation, and we're not coming to it necessarily from the background of the traditional automotive industry. And I think that that's really worth mentioning. And that's a cornerstone of the way that Red Hat approaches these problems too. We do all of our work in the public and open source projects. We're doing the work on our in-vehicle operating system is all being done through a special interest group within the CentOS project. For example, we're founding members of the Eclipse Software-Defined Vehicle Edge project that is just now launching. We're members of a number of different industry organizations focused on doing all this within open source. And specifically for some of the largest challenges are going to be, I think, with functional safety certification, as has been mentioned. We're leaders within the ELISA project, the Enabling Linux and Safety Applications through the Linux Foundation. And there's a ton of really interesting work going on there in terms of bringing a much more performant and flexible operating system ecosystem into the automotive world and into a number of other worlds also that require functional safety certification. So I could keep up. I think you're on mute.
Oh yeah, I was just going to mention too, Nichelle's joined us. Thanks for being with us on the panel too. I'd like to get Scott's perspective. I guess some folks who we haven't heard from yet too, just like you, Jeffro. We've talked about the massive amount of data that's being generated through all the telemetry on vehicles, but not just vehicles. It's road systems, it's traffic systems, it's performance information, it's improvements, it's customer experience data. I mean, the list goes on forever. How do you think about those changes in terms of how we manage and think about data that's not only being consumed, but also generated by effectively every vehicle is its own cloud? I mean, we're really talking about not just edge, it's truly like a multiverse of clouds.
Yeah, so you hit the nail on the head there. The data generation rate just continues to double and double and double again. We love over the past 20 years talking about Moore's law and processing power, but if that is a rapid increase, and does start to tail off recently, the rate at which we are generating information is in exponential growth. So systems have to be able to cope with that, and there's a few different ways to do that. One is a really high performance database system. That's what we do at Couchbase, but some of it is also being smart with that data. What data is relevant and actionable, and what of it is just junk? So being smart with that. And then as this data becomes more and more important, back to what Andreas said, the security element is almost impossible to understate at this point. And I'll put it to you this way. A ransomware attack on your laptop is a real pain and can be a nightmare. Imagine a ransomware attack on your car when you're driving it. It's you're going to be very motivated to pay it. So, and you're even more motivated to not be in that situation in the first place, because it now threatens your physical well-being, not just your digital one. So, being able to lock that data down and yet do so while ensuring its availability to the correct users, and enabling all these cool new experiences. I mean, I love the idea of, I'm not ready to trust my life to it, but I love the idea of being able to take a nap on a long drive. I race motorcycles up and down the East Coast, and some of the tracks I go to are 8-10 hours away. And if I could autopilot even half of that drive and sleep or work or eat or whatever, it would be a huge boon to me, and I would shell out some serious dough to make that happen. So, and I think we can all think of things that we really wish that next iteration of this technology would bring to our individual lives, and I think that's where the data is ultimately really going to be powerful.
Definitely brings new meaning to the term carjacking.
Yep.
Yeah.
Alexander, we appreciate your presentation. Any additional dots you want to connect in addition to what you said in your presentation?
Yeah, well, I think it's a shift in mind. If you think about there came a person called Elon Musk, and they took a computer and built a car around it. And when I think about the history of the car, I mean, in I think it's 1885 when Carl Benz invented the first motor car. Henry Ford made it affordable to the people, and they built a car, and then now they build a computer into the car, and you see that there are some differences about this approach. And I think that's also important to understand that this is really a cultural change which we are talking here about. It's really a cultural change, not only within the company that provide services or build cars, but as well for the consumer. So it's really for everyone a real change in history.
Great. Nichelle, anything you want to add from your conversation?
Yeah, I think that's where we have been seeing a lot of initiatives in the industry. I mean, Tesla has been a trigger, and we do see all the car makers taking more and more control in-house. If you take examples of the big car makers, they're saying they would move for less than 10% of software in-house capability to almost 80-90% kind of a thing. That's a huge, what do we call, capabilities that are needed. And that is exactly where we see some of these where do we get those kind of engineering base to really scale up? And that is where I think when we were talking of open source technologies, you will be the trigger point to expedite and adopt these kind of a massive changes needed. If you really look, when we say Linux, that was adopted by Tesla and others, were a big no-no, probably even a couple of years back now. But we do see now, and that's why Red Hat is entering into these domains to get safety certified infrastructure components which can be readily used to expedite these kind of innovations. We have seen that happen in telco. We have seen that happen in other industries. Now automotive is the next frontier.
There's a lot of buzzwords that we can use, convergence and things like that. It seems like some of the fundamental shifts that are underway, I use paradigms to describe. One is we've personalized automobiles forever, right? Since Chevy kind of came out to differentiate from Ford in the early days. We're in an era now where that's essentially what's going to happen with software in our vehicles, whether we're subscribing to them, whether we own them, and it could be any part of it. Just like I might load my own operating system into my router in my home for Wi-Fi, people are going to be doing that to vehicles. So we're entering or in an era where it's not just manufacturing, it's living with the life of the vehicle. Tesla has demonstrated that for us, right? Software upgrade, introducing new features. It's a different kind of mindset. How do we think about the software flow, Andreas, and the life cycle of not just a system, but a multitude of systems that all come together? Some of it we control, some of it are completely outside of our control, some of it's through partners. It's a different mindset, I would think.
Correct. Yeah, so thank you for that. And remember the cliche, a lot of things changes, but a lot of things stay the same. So what we are seeing right now is no different than explosion of complexity. You know, what do we do when we have an explosion of complexity? We have solved this problem before in different industry or different field, right? But one of the key important thing in building automotive software now is the ability for you to see the process. So seeing is the first step. Make sure that all the processes interconnected between the supply chains, you can see that, right? And then the second piece is understanding dependency, which is very important because now the dependency is just becoming a massive spreadsheet. Spreadsheet cannot handle it anymore because now there is a complexity between dependency between hardware and software, right? And then the third piece is once you can see, once you understand the dependency, you need to be able to measure. Measuring is very important because by measuring, whether you are actually operating at the optimum level or not, having that real-time data, what happened to your software development process that actually interact with the hardware development process, and understanding the bill of the materials. When you are able to measure that, then you can react to any issues faster than before. That's where now that concept of agile can actually be implemented in the building a car. So to me, seeing, right, dependency, seeing the process, understanding the dependency, and then measure. Those are the three things that is important to handle exploding complexity.
Who wants to comment on that? Love your perspective. Jump in, somebody. I'll pick somebody. Jeff, oh, you go.
Well, it strikes me that I totally agree with what Andreas just said, and it strikes me that that really reflects the standard development model of understanding the system, understanding all of its dependencies, and then as you're building it, testing as you go, and refining that. And you know, maybe it's my perspective as a longtime open source guy, but I would always bring that back to the open source process. Whereas the more eyeballs you get on something like that, and the more disparate of a community that you get looking at that process, that the faster it will actually go, and the farther it will go.
It's also notable that no one on the panel is a pure play embedded system company, right? Software, both can be embedded as well as not. It seems like our pipelines, our software delivery pipelines, how we innovate and how we create software also has to change, right? I mean, maybe, you know, delivering several production deliveries a day isn't really the model anymore either. It's a continuous, constant flow for customized, personalized, individualized products and services, including down to the data that's consumed and used. What from a data perspective, either Alexander or Scott, how do you think about how we're going to change how we create software?
Yeah, well, I think when I think of the history of especially of databases, when I come to that point, we see that we are working with relational database systems for long years, for decades now, and they're pretty good for all kind of handling of data, of analytics and so on, but only to a certain point when it comes to, and that was what I was also pointing out in my presentation, is when it comes to performance at scale, when you do not have only 1,000 users within a company, but need to serve millions of users, of consumers out there, millions of cars out there, and want to handle that kind of amount of data, you need a data platform that is scalable with this amount of data, not only with the amount of data, also with the reads and writes of the transfer of data that come with it. And yeah, and I also think that flexibility is a much important thing. As we think about an ongoing process, we need to be able to adapt the database within the software development process. And this is something that NoSQL really is designed for. So if you're thinking about a NoSQL database where you have a, let's say, more semi-structured way of storing data, and not the really totally normalized way that you would do it in a relational database, then you're much more, when using NoSQL and using document databases with these JSON documents, you're much closer to the object model of an application. And if the object model and if the application should change, you will be easily able to change as well the data schema in the database. And I think that's also an important thing when you think about the right database, the right development methods, to be flexible, to be agile in development, and all these the complete ecosystem needs to support this type of process, this high level of flexibility and agility as well.
Jeff, I know that Jeffro, that I think something that you had brought up about open source. How do you think open source might change in the role that it plays in this dynamic and large of an ecosystem?
Well, what I've seen over the years is that open source has helped to transform a number of industries. Some of them, arguably at scale with automotive. Certainly telco, it would fit into that capability. I see other industries that are in the process of transforming. We work with a lot of energy systems, oil and gas and utilities as well, that are in the process of transforming and what they call digitalizing, which is not a term that I really like, but it's really true that they're moving from physical systems into digital systems and more software defined things. And in that case, I think that databases and what Alexander was just talking about are going to be key. We have to have flexible data systems in order to accommodate those kinds of transformations, because some of these are legacy systems that go back 150 years. Certainly electricity goes back to the 1880s, and as it transforms, we see automotive going through the same transformation. The data is really going to be key to it, and it's going to be key to security as well, as Andreas was saying a minute ago.
I also want to note, I know we're doing a giveaway for the webinar today for a pair of AirPods, so we'll announce that at the end of our panel. So stay tuned, find out if you're a winner. I'd like to bring up, we talked earlier about the nature of the large number of participants, collaboration, technologies, companies coming together, both through design all the way through delivery and life of a vehicle and services that go with it. Some of that cultural brings with the cultural differences. Just how would we get the best of European, German engineering with the Silicon Valley agile, fail fast, entrepreneurial? Not saying that others aren't as well, but those are sort of the mantras of different cultures. Is that going to be a clash of cultures? How can we get the best of both worlds in a technology setting in the automotive industry? Nisha, I'm going to pin that on you, that tough question. Let's see what you can help us with.
Yeah, I think that's a great question. When we look at all the suppliers for the technologies that are coming in, be it the Google, the AWS, the Microsoft, and even when it comes to semiconductor vendors, be it Intel, NVIDIA, Qualcomm, I think innovation, that's where the bigger technologies and the newer technologies are originating, and we no longer have these boundaries have to crumble, and we have seeing all these car makers embracing these kind of what do we call cultural barriers, and we do see the footprint of all these big car manufacturers are now spread across various geographies. If you look at Volkswagen, Carrier, they have their centers all in Asia, in US. If you look at GM, they have their thing in Israel, and we do see in any cause we have all these kind of a global footprint collaborating to develop the next generation platforms. And we ourselves as a Red Hat, whenever we get into call, we always have no two people from the same location. So I think that's the reality of the modern world. And we even see a co-opetition kind of a thing elaborating. For example, Volkswagen and Ford investing together in Argo for their autonomous driving. We have all these kind of acquisitions coming into picture. So I believe the next disruption is all about who gets the best technologies and platforms. And I think there will be a big cultural shift. Automotive, which traditionally have been so orthodox, very inward looking, is now keeping pace with other industries. And we do see a completely different platforms getting into picture in another couple of 2-3 years. Not earlier, we used to talk of 5 years and 10 years, kind of a life cycle. It's now getting reduced to years and months, speaking wise.
Mm-hmm. Alexander, I'm curious your perspective. Is that part of the solution of the geographic distribution of organizations and teams and helping blending those cultures?
Oh yes, I think that's as well something that needs to be taken in consideration. And when I think of and I bring the sample again with Tesla when they started and came up with their first models, of course. All these companies, these engineering guys, they looked at it and said, "Hey, the hardware is not great, not fantastic." So yeah. But today, if they look at Tesla's stock price, then maybe they think where the travel will lead them, and that's the way it will come. This is disruption, and I think if I look and I can only speak for the German car manufacturers, they all started to set up their new think tanks, their new subsidiaries that exclusively think about that new future, developing stuff and so on. So that's really amazing to see what's ongoing in the industry.
Interesting. Great response. I'm curious too. I'm going to make a loose, you can say if I'm stretching this a little too thin, but Jeffro, it seems like with open source proprietary software models, the bazaar and the cathedral, back to that book at the start of the open source or early days of open source. In a way, we've kind of gone through this transformation of blending open source and commercial software into a really, I think, productive, great results ecosystem. Maybe that's a model or some lessons we can take to how we get the European German engineering, the manufacturing strength and design skills of India and Asia, and of course the entrepreneurial Silicon Valley spirit. Are there some lessons there?
Well, one thing that I take from it is that the approach that I hear coming from all corners of the industries is that any solution has to be holistic. So it has to take into account all of the strengths of all of these, geographical areas or educational areas or functional areas, where you really want to take the best of the best and use that as the basis to start again and move forward. And that, in the next generation of technology, we'll be building on the shoulders of different giants. And so in that case, this has always been an issue with open source. I've been in open source now for about 30 years, since the early 90s, long before we called it open source. And we've always had what we call the round earth problem, where getting people into a meeting who are in Asia and Germany and Russia and the United States, and it has always been a challenge. And I think that that challenge really speaks to the holistic nature of this. I don't see it necessarily being geographically disparate. I see us picking the best from each of these areas and moving forward with it.
Excellent. Scott, we're talking about the data side of this. We already deal with a lot of complexity in regulatory environments, local, national, geographic, and disparities between them, and different paces of how compliance requirements are brought to the market, imposed on manufacturers, software suppliers, whatever it might be. I imagine that's not going to get easier. It's going to get more complex. How do we manage the data from that perspective of being able to get the right compliance information so we can deliver software quickly, but also meet compliance requirements, whether it be safety or personal privacy protection?
Yeah, I mean, that's going to be everywhere, and it really ties back into other things we talked about. What Alex said about the agility that a NoSQL database enables is going to be really important, because if you can't respond, you may not know that something was in committee until it's 3 weeks from getting passed, and then you've got hopefully they gave you some runway to get to compliance, but you're dealing with a whole bunch of potentially moving targets. Another area that I think is going to, we've got security, we've got privacy, we've got the on-road regulations, but another area that is going to, I think, start to become increasingly difficult for technology in mobility is power. As more and more electrification takes place, we're already seeing we're already seeing California say, "Hey, well, can you not charge your cars, at peak hours because the power grid can't handle it?" So that's going to be a regulatory thing. It's going to be when you talk about the range, one of the biggest stats everyone looks at when they look at an EV is what's the range, and what's the real range, right? What if I have the heat on? What if I have the air conditioning on? What if I have the radio playing loud? All of those things consume power, and therefore all of everything draws from the same bucket, the same where in a gasoline powered car, while that's still true, it's much quicker to refill, and frankly your alternator is running whether you're listening to the radio or not, using the air conditioner or not. Some things like air conditioning do have a mechanical drag that they place on the system and can impact your range, but those systems are now so efficient that it's not a big concern. If you look at some of the independent testing of EVs, it's a real concern. So I think it's important to keep in mind that all of these systems consume power, and therefore efficiency that can be gained on the tech side can help translate into efficiency in driving, efficiency in recharging these vehicles. And I think that's going to be an area that has not been sufficiently addressed, but will need to be going forward.
Great. Well, we're kind of coming up on the end, and I'll give you a chance, or Andreas, and you want to jump in too. So let's move to our lightning round question. We have about 6 minutes left. I do want to announce the winner of our AirPods, and that is Patrick Verpalen. So the folks here will get a hold of you after the webinar about how to get your award, the AirPods. Let's wrap up with this kind of lightning round question. So if you would each take a minute or so and share your thoughts. Manufacturers have dealt with supply chain integrity, managing just-in-time inventory, all those kind of things for a long time. Software supply chain is a hot topic for security reasons, but also thinking about our changes in our ecosystem. What's one takeaway that you would say, this is part of where I think we need to do more work right now in thinking about how we manage our supply chain? Andreas, I know that's a interesting topic that you're passionate about. You want to start us out?
When I raised my finger earlier is actually to comment on Scott about compliance and regulation. And this challenge with supply chains is exactly that. How can we bring transparency? If a supplier supply a component, how can you actually provide a clear audit trail and a bill of materials? What happened to this module? What is the difference between this current version and the previous version? So audit trail and a bill of materials is becoming very crucial in the new world of supply chains, because only with transparency and a complete bill of materials and audit trail, then you can ensure security. If it's opaque, then you don't know what happened to it, and that's when risk of security can creep in.
Fantastic. How about Alexander? How about you?
Yeah, well, looking at the focus of the database, I think it's what we can deliver to this supply chain will be, of course, the way things are deployed, and I think that's also an important thing, that you be flexible when thinking also about a global distributed solution, which it will be for sure, to have an infrastructure to be able to rely on globally that supports these kind of infrastructures that work around the globe. I think that's also an important thing that these kind of solutions will need to deliver.
Excellent. Nishal, from a Red Hat platform, open source perspective.
I mean, that was always a question when Red Hat entered into automotive, as we saw with the new products. We had discussions with some of the car makers, and it was really encouraging to see how car makers are looking for the future to upgrade, modernize, get in pace with the changing technology. There is either change or perish kind of a situation right now. So this is a defining moment for the industry, and we are really happy to be part of this and really set a tone and also set a kind of help the industry to go propel forward with adopting the new way of working, open source innovation and open culture, and that will be a big reset button, I would say, for the automotive industry.
Great. I'm gonna break all the rules, Jeffro, and have you go right after your colleague. So go for it.
One thing I would just add to what everybody has been saying is that the open source industry or ecosystem, however you want to put it, has been very strongly in favor of transparent development for a very long time, and that software bill of materials has been on the watch. I know that we've been dealing with it since I have been involved with embedded Linux, which is going on 15 years now. I would want to give a quick shout out to the Linux Foundation for creating two different projects that address this. One is an SBOM project that is in development. And the other is a project called Open Chain that's run by my friend Shane Coughlin. And it's all about transparent supply chains and making those supply chains secure using standards. And Open Chain is now an ISO standard. So these things are happening within open source, and I think that they're proliferating throughout automotive as well as many other industries.
Yeah, definitely shout out to Linux Foundation. Some great stuff happening and continues to happen. How about you, Scott?
Going back to what Alex was referencing about the global nature of things, I think that's important to really focus on. All of these supply chains are going to be globally distributed, and that also brings us back into the regulatory world. So the database has to support the ability to comply with both data availability in a global way, and in a fast way. Everybody's tried to remote desktop to a system far away, and everything's in slow motion. Your mouse cursor moves about an inch a minute, and that's really frustrating. So it has to perform well, but then you also have to deal with the security requirements and data governance requirements. Data from the EU has to live in the EU. Data from Russia has to live in Russia. That is becoming an increasingly national, or in the case of the EU, kind of multinational standard that is going to require some adaptation on the part of the data side. We have to comply. If we don't comply with those rules, we get hit with big fines, or we can't do business in that country. Those are unacceptable outcomes. So having a system, and this is something that Couchbase is very good at, that makes that easy. I can seamlessly replicate the data I need to replicate from place to place, and then localize the data I need to localize without adverse impacts or exorbitant costs.
Well, this has been a fantastic panel. I guess I'll wrap up before I turn over to you, Sebastian, just to add the thought. One of the things that's changed in my thinking pretty significantly in the last few years is nothing's at rest anymore. Nothing's static. Nothing has just one state and stays that way for very long, or if ever. Everything is in constant change. So I kind of moved from a world of thinking of things are occasionally in a solid state till everything is a perpetual fluid. It's a liquid. It's just continually moving, and every time we touch it, it's like a river. We're touching a toe. We're adding a new container, microservice update, whatever it might be, to that world. And there's so much we have to kind of rethink about things extending their life, whether it be us, how we work together as a technology community, or the life cycle of a vehicle. Once it leaves the factory, it's not over. It's only beginning its evolution and change as a product. And that's a very different mindset, certainly for a consumer as well as all of us involved in this. So thanks to each of you, you in your own way, in your own expert areas, and your contributions to the panel. And of course, thanks to CloudBees and Couchbase and AWS, Red Hat, Techstrong for putting this panel together. Sebastian, turn it back to you. Thanks for you for hosting too. You fantastic job.
Yeah, thank you. That was really colorful and insightful, and thank you for these warm, foreseeing words at the end, Mitch. That really packed it in a nice way. But yeah, I think also to the audience, thank you for staying with us the full 2 hours. It has been packed with different things, and more will come. Yeah, we will send out an email with the recording, and if you are interested, reach out to us, and we will get back. Yeah, I think that's most important, that everybody learns something, but also maybe can go further with the insights. All right, then I think Max will the winner of the raffle.
Yes, it was Patrick for Palin. So we will be contacting you afterwards, Patrick.
Yes, so we will also stay in contact here, and yeah, congratulations again, and yeah, see you another time. Thank you very much. Have a nice day, evening, night. Yes. Bye.
Goodbye.
Bye-bye.
It was a pleasure.
Bye, everyone.